Okay, it's 8 o'clock, so it's time to start our live stream tonight. I am very pleased to welcome all of the audience here on YouTube, and I'm even more pleased to introduce our speaker for tonight, Paul Salazar. And if you wonder where this voice is coming from, I can tell you I'm not the alien you see in our waiting picture. I'm just Benjamin, the moderator of tonight's talk. And of course, the most important person tonight is Paul Salazar, which you can already see in the corner right down in the picture here. So, Paul, may I introduce you briefly?
Thank you, Benjamin. Sure.
Okay, so Paul is a member of the Volkssternwarte München, and we got to know each other some years ago when Paul offered to give presentations in our lecture hall, which of course at the moment is closed, and so we switched to live presentations on the internet. But if we're lucky, we can repeat the talk maybe in the future, and then you can directly talk to Paul in one of his future talks then. Paul loves to encourage people to observe the night sky, and he has a nickname. He calls himself the urban astronomer, and he also writes for a blog. He has set up a blog more than 10 years ago, I think, where he describes what you can see even in light polluted areas with the naked eye. So there's a lot of hints for you if you want to go out and watch the sky and see interesting things there. So check it out. It's down in the comments below this video. But of course, now I like to invite you to listen to Paul's explanations about extraterrestrial life in the universe. And just to have some mentions about the about how it works out. If you have questions, then just write them in the live chat. I will have an eye on the questions, and if they're really important, I will pass them on to Paul. But we prepared a questions and answers section, which will take place after the talk, where I will pass your questions to Paul and try to put them in a meaningful order, and where you are really invited to pose every question you may have about regarding extraterrestrial life in the universe. And now I'm very happy to listen to Paul's ideas about that topic.
Great.
Have fun.
Thank you very much, Benjamin. Glad to be presenting this evening. And as much as I enjoy doing this live at the Sternwarte, doing it live on video, let's see how it goes. I think we'll have a good time. It's a fun subject and an interesting subject, and one that really, quite honestly, has been a question that humankind has asked for not just centuries, but millennia. This is an age-old question to wonder when we look up into the sky at night and we look into our universe, and to try to think about the question, are we alone? Is it possible that in the entire expanse of the universe as we know it, that we might be the only place where there is life? Or is there a chance, or even a very high likelihood possibility that somewhere out there is life? And then the question we ask ourselves is, how could we know that? How would we discover that? So tonight I'm going to share with you some ideas and thoughts in a very structured way to try to put some light on this question and explore it, and hopefully you'll have some questions as well that you can ask in the chat, and we can discuss those as the program goes on or toward the end. So We always hear about people who see UFOs and talk about little green men that have arrived on Earth. And we make movies about evil aliens that come and want to kill people and destroy cities. We even make fun movies that are silly and adventuresome about aliens. But really, for tonight, I want to be doing this discussion in a more thoughtful way. This is a more serious look at the question of extraterrestrial life and extraterrestrial intelligence. And in doing this presentation this evening, I'd like to give you the overview. How are we going to explore this subject? It's a very vast subject. There are many little pieces to the story. And I want to help you to get a basic understanding of, first of all, some of the principles, if you will, some definitions of what does it mean when we talk about extraterrestrial life, and for that matter, extraterrestrial intelligence. And that is not a simple subject. I actually will break this into 5 different small conversations. And then we'll go into the question of what are we doing today, meaning where on planet Earth is there research happening to try to get to the deeper meaning and answers to some of these questions. And then we'll take a quick look into the future, some of the future areas, things that are being planned and proposed to go even deeper into these areas of research and to improve our knowledge. And at the end, as I mentioned, and as Benjamin mentioned, we'll have some questions and answers, and I'll have some challenge questions for all of you that are listening. I want to give you some provocative and hard questions to think about to stimulate your thinking and your enjoyment of this subject, because as I said, it's a fascinating subject. It really can be very deep. And toward the end of the presentation, we'll touch on some of these challenges, as I call them. The one thing I'm not going to cover, sorry to disappoint, is UFOs. Although that's a very interesting subject, and there is a lot of interesting literature out there, for tonight's talk, I'm going to stick primarily with what's being dealt with in terms of pure scientific research and attempt to make it not boring, but fun and interesting and challenging to you. And as I said, to kind of give you some new ideas to think about. So, ready? Get set? Let's go. So, we have to start with some definitions. There's an entire field of study called astrobiology. So it's biology, but biology of what life could or would be like beyond Earth. And when you think about that, when the astrobiologists are doing their work, they really have to get to the fundamental question of what does it take to create and sustain life as we understand it. And so what we do is we start with our own home laboratory of Earth, and we try to understand what are the core elements of life. And one thing we know is all living creatures on Earth have some biogenic element in them. Carbon is the most common thing, and actually quite nicely, carbon is one of the most common elements across our entire universe. And along with nitrogen and silicon and oxygen and phosphorus and sulfur, these are some of the core biogenic elements, which means they interact really easily to form biomolecules. So these are the foundation materials, and because they're not only here on Earth, but everywhere in our solar system and our galaxy and our universe, well, that means there's at least a foundation of life potentially anywhere. So what else do we find when we really dissect the elements of life here? There's an idea, a term that's used in the scientific circles called a solvent. There has to be some sort of a solvent, something which flows and interacts with those biogenic elements. Now on Earth, the most common thing we have is water. That's used everywhere. And of course, virtually every type of life we see on Earth is going to require water. Even in the most minuscule amounts in the desert, there still is a need to have water mixed in with these biogenic elements to get life. What we don't know yet fully is whether you could have these same biogenic elements mixed with a different solvent like ethane or methane or ammonia and still get a life-sustaining platform. So that's one of the interesting areas of astrobiology that's being studied right now. Another thing we know on Earth, of course, is we need energy. And that we have in abundance coming from the sun and from other sources inside of the Earth itself. So we believe that without the energy, of course, you've got to have something which kind of cooks, if you will, right? Which kind of cooks the elements as they mix with the solvent, and that becomes a platform. And of course, we need time. Our Earth is 4 billion years old, and there were tiny single-cell life forms and 3 and 4 billion years ago, but it took literally billions of years to get to the point where the evolutionary process has enabled those small, simple life forms to evolve and advance to where we are today. You do need time. So, if you do that long enough, if you have time with some basic elements, biogenic elements, and you've got some energy sources and a solvent like water, we're quite familiar with the idea that you can have microorganisms. And that is the start of life. That's how it began on Earth. Those are the foundation types of life that we came from. And from these, you can begin to build. But we're just going to start simple. So at the most basic form, you take these elements, you blend them together, you can get microorganisms. Now, we know on Earth, that's our only experimental platform we know of where life has emerged. So we know on Earth, if you blend those together, we get life. The question is, the astrobiologists are asking is where else might you find the right conditions with some of these same factors as the building blocks to yield other kinds of life? And certainly if you look within our own solar system, the most obvious places to look are planets and moons and asteroids. Okay, those are big rocky surfaces of one type or another. And if you have these various elements blended together, these various factors, that could be a place. But let's go a little bit further into that. This is an image of a typical solar system. And whether we're talking about our solar system or for that matter, any of the thousands of solar systems we've now discovered, planets orbit their star. In our case, Earth is orbiting the sun. And if you look at this picture, Earth would be orbiting in this green zone called the habitable zone. Why do we call it that? Well, if you get too close to the sun, it'll be too hot. And that's what's happened at Venus. And in Venus, all of the solvents have been heated and overheated to the point where they've all evaporated. And Venus is blanketed in clouds. And there's no more running liquid on the surface. There's no more ice either. If you go the other direction, in our solar system, the next good example is Mars, the planet Mars. It's outside of the habitable zone, or barely outside of it, and it's too cold there. It's lost a lot of its atmosphere. It doesn't trap the sun's energy very well, and it basically has frozen subsurface ice, water. But it doesn't have anything flowing. And the great thing about Earth being in the habitable zone, or just the right distance away from the sun, is we enable water to exist in all three of its states. It can be in the ice, solid. It could be liquid, as water is flowing. And it can be as a gas, as in terms of water vapor. And that is a magic formula to enable what's happening on the surface of that planet, if in fact the planet has those other factors. So let's go a little further. Got to be in the habitable zone, right? So we need a planet, a moon, or an asteroid in the habitable zone if we're going to create some life. And we like having a rocky surface because we need those biogenics. We need those raw elements like carbon. And by the way, we have other planets in the solar system like Jupiter and Saturn, Uranus and Neptune, but they're not rocky planets. They don't have a rocky surface. They have a gas surface. So they're not as inviting for life as we understand it. You also need to have, of course, that solvent. Now we have water on Earth. We will talk later about other worlds in the solar system where they have oceans and lakes that are made of other solvents. Could be something going on there. And we need a stable energy source something which is stable, as I said, for not just thousands or millions of years, but in our case, for billions of years. Because there are some stars that have planets going around them and that we've discovered who are less stable. Their energy output varies greatly over days, weeks, or months. And that would be an unstable environment. If the temperature radically goes up 10 or 20 or 30 degrees and then down again over the course of a long span, that's less hospitable for life to emerge. So we need that stable energy source. And since we're on the subject, there's a couple of other things that help out. For example, tidal flexing. What does that mean? That means that there's flexing to the surface of this object because of tides. An example would be the moon. Our own moon going around our Earth leads to tidal bulges, leads to the tug and the pull, the gravitational attraction from the moon that actually helps to keep the Earth in a more active state. Active planets or asteroids or moons that have tidal flexing can release heat from inside of that body. So not only are they getting energy from their star, but they're getting energy from inside their own surface. So that adds a new dimension, and it helps. And we have the magnetosphere and the atmosphere. So that means that around Earth, for example, we have a beautiful blanket of air, which is quite important. And we have also less, not visible, but equally important, a blanket of magnetic fields that surround the Earth. And those magnetic fields do a great job of protecting us from a lot of the radiation that comes from our sun, radiation that would otherwise be lethal to life, certainly for human life. And as well, that atmosphere is quite nice at slowing down and helping to disintegrate a lot of the inbound asteroids and meteors that are coming our way. So these are a little subset of things that if you want to find another planet orbiting another star, what we call an exoplanet, these would be the kind of characteristics you would want to have in that environment in order for there to be a shot at getting life as we understand it. Here's a little diagram. Now, we've been busy as a human species to going out and discovering exoplanets, and we've discovered thousands. And of the thousands of exoplanets we've discovered, many of them are very large. Those are easier to find, you might imagine. The bigger the planet, the easier it is we're going to spot it. And a lot of those are what we call hot Jupiters, like our own planet Jupiter, and they're not a good place to expect life. But the more challenging ones to find, yet we found many of them, are what you see on this diagram, are the more Earth-like, rocky type planets that have the potential to be habitable. So there's a lot that we've been discovering over the last decade, even in the most recent few years, that expanded our knowledge greatly in terms of the likelihood that there could be exoplanets. So now we're looking out to the exoplanets. We understand some of the characteristics of what's needed to support life brewing in these places. What if life was there on one of those exoplanets? How would we even know that? How do we spot life in action when it's hundreds and hundreds of light years, billions of miles away or kilometers away? Well, we look for what we call biosignatures using a technique called spectroscopy. That's a technique in which, like looking at light from the sun when it goes through a prism and it's broken into its component colors in the rainbow. That's giving you some insight as to the sun and what are the components in the sunlight that we're able to then better understand when you put them through a prism and you can see all of the individual components. We can do similar things. We, meaning scientists that study these things, spectroscopy, are able to then decipher and look at these exoplanets. And if that exoplanet is moving in front of its star and the light of its star is shining through the atmosphere of that exoplanet, we would be able to detect signatures. Signatures just like looking at a rainbow. But imagine looking at a rainbow, but the color green is missing. you would say, well, there must be something going on that's blocking that color. In a similar way, when we have oxygen in the atmosphere, or methane, or water vapor, or hydrocarbons, or ozone, there's going to be a gap. There's going to be certain parts of that spectrum of light that would be coming from the star that might be missing. And that would guide us to understand that that planet that is at that moment in front of the star, blocking some of the starlight, might possess some of these biosignatures, which is telling us that there's probably life down on the surface. So that's one way. And in fact, there's even further analysis of this very type of technique. And there are scientists engaged in trying to understand, what if there's a life form that's, again, it's based on ammonia instead of oxygen? And maybe it's not based on carbon, but it's based on silica. And it has a different signature, a different spectrum in the way it presents itself. Can we begin to imagine different groupings of different elements that would represent a wholly new life form that we haven't seen before? But it gives off its own very unique biosignature. Isn't that fascinating? That's how it works. That's what we're looking for. We, meaning scientists who are analyzing the data, when they look out to the exoplanets. So you can look out, and with very careful science, you can begin to look at these exoplanets and evaluate, are there biosignatures? Are there, if you will, outgassing that's telling us something unique about the potential for life? But that could be, once again, little microorganisms that are living in little oceans that are giving off these signatures. The question we won't be answering just by looking for this is a deeper question. And that's the question of intelligent life. What if there was a planet out there that not only has these microorganisms, but also possesses much more advanced life forms? How would we know that? How would we be able to detect at a very vast distance that another world that we discover could possess intelligent life? Well, the first thing we have to do is give intelligent life a definition. So, what are the things we do when we think about human beings on Earth and we compare ourselves to other animals or other plants or life forms on Earth? What distinguishes what we might call intelligent life on Earth? That's a good question. Think about it. What would you use? What would you say are the factors that distinguish us? Commonly in the world of science, there's 3 factors. There are many more, but some of the top ones is that this life, whatever it is, understands and can impact its environment. So it can rise above just being an existing living being and actually manipulate and change its environment and adapt it for its own survival. That's one. We'll come back to this in a second. The second one in here is it can develop and improve technology. What does that mean? Well, technology, building tools, building advanced tools, building complex systems, and integrate those into their society to help them survive. And the third thing, they radiate signals. That's actually one other measure of what is intelligence. That an intelligent civilization, wherever it may emerge in our galaxy or in our universe, would probably be radiating signals. And more specifically, signals that are narrowband and not random. We're going to come back to that in a few moments. But let's apply these ideas. We can understand and impact the environment. We develop and improve technology and integrate it to society, and we radiate signals that are narrowband and not random. So, for example, using those definitions, this is not intelligent life. This collection of animals living in the open spaces are not adapting their environment to suit their needs. They're living within the confines of what they have. They're not using any kind of technology to advance their species or build societal structures, and they certainly as a mass of living beings aren't radiating anything unique out into space. So we would not categorize this picture, this grouping of animals in Africa, as intelligent life. So if they're out there on an exoplanet right now, we're not going to know it any differently than if it was just microbes. We would recognize the biosignatures in the atmosphere and say there could be some life down on that planet, but we wouldn't necessarily call it intelligent life. However, for better or for worse, this is a picture of intelligent life, because this society that you're looking at here in Times Square in New York City has certainly adapted its environment for its own survival, right? It's paved over land, and it's built an environment that allows it to sustain many, many, many more times the population density of what might normally be living in that exact same space. And they're using extensive technology, whether it's electricity, whether it's transportation and vehicles and engines, whether it's all of the compute power that's built into this environment that helps and sustains it. But finally, it is definitely a radiating place, and I mean that in the most literal sense, that it is radiating signals at low frequencies, at mid frequencies, at high frequencies across the spectrum. And because we have an atmosphere, some of those signals don't ever escape our atmosphere, but many of them do. And that makes an intelligent life a very noisy place. So if you want to go out and discover where is intelligent life, one of the techniques that the scientists will use is simply to listen more carefully across the electromagnetic spectrum for the kind of signals that would be generated. And as I mentioned on the previous slide, it would be signals that are in a narrow band and are not random. Like if you were to pick up a TV broadcast, or a telecommunications tower, or a satellite communications system that's communicating to a weather satellite. Those would all be sending out signals that are very narrowband and are also not random. And we would characterize that as symbols, as if you will, evidence of intelligent life. Interesting. So let's recap what we've learned. Number one, the world of astrobiology and the astrobiologists that are deep in this field have helped us to begin to define the basic elements that are needed for life. Life as we know it here on Earth, and also they're creatively trying to evaluate what might be other types of ways in which life could manifest elsewhere in the universe, ways that we can't even conceive of yet. Where do the astrobiologists look to find the building blocks? They look at planets. They look at moons of those planets. They look at asteroids that are drifting through a solar system. And what do you need to enable that life to emerge? You need to have those biogenics. You need to have the energy sources. You need to have the solvent of some kind or another, and you need to have time for these things to work together. How do we spot the life? Again, it's the outgassing, if you will. It's the atmosphere around these various objects that have telltale signs in them that we can detect through spectroscopy. And how do we know if we find intelligent life? We're going to be looking for these telltale electromagnetic signals that are narrowband and not random. So hopefully that makes sense so far. That's our foundation knowledge. Now let's think a little bit more about how do you go out and look. What are the different endeavors that are happening right now in the scientific communities all around the planet that are utilizing these fundamental principles to now go out and try to find stuff? So we'll look at the current areas of research, some future areas, and then we'll come to our challenges and questions. What are some current areas of research? First, rather amazingly, for the last 50 years, we as a species have been technically skilled enough, technologically advanced enough, to actually send our own spacecraft all over the solar system, sometimes even landing on other objects, to do direct investigation. We also look out beyond our own solar system with telescopes of all different types, radio and visual telescopes. And we look into our Milky Way galaxy, and we've been discovering quite well now a lot of exosolar systems, that is to say, planets going around their own stars that are not here. Exoplanets around their own stars. And we evaluate what we see. We can also look much deeper and much farther out, far, far, far beyond the Milky Way galaxy into other galaxies and other parts of our universe, and listen carefully for those telltale signs of intelligence. And finally, there's another area where we can actually send our own signals out and broadcast, hey, we're here on Earth, come meet us. That's a very controversial thing, by the way, so we'll come back to that in a moment as well. But let's dive into each of these four subjects very quickly. The first one is we have been, as a species, as humankind, for 50 years going out and sending out our probes. And we've sent them out, obviously the first stop was the moon, but very soon thereafter we got to Venus and Mercury and Mars, and then we got out to the outer planets, to Jupiter and Saturn and Uranus and Neptune, and even just a few years ago to Pluto, finally. And even around some of those planets, like Jupiter and Saturn, there are some amazing moons that we've come to know that are absolutely fascinating. And along the journey, we've also met and come to know quite a few asteroids as well. So all of these are, interesting objects to learn about. But in this journey, let's call it phase one of our research, of all these objects, we found some that were more interesting than others. Mars contains a lot of the same elements as Earth and has frozen ice, has frozen water on it. Enceladus, one of the moons around Saturn, has very interesting ammonia oceans frozen under a layer of ice, flowing under a layer of ice. Titan, one of the biggest moon in the entire solar system, has potential, has some of these same elements, some of these same characteristics of having the right biogenics and the right components. And the last one is Europa, one of the moons of Jupiter. Once again, these are the four candidates that after scanning all around, we thought we should go back. Because the first time we flew past a lot of these different objects and landed on them even, we discovered general science and general information. We didn't find life right away, but now we want to go back with a more careful and more thoughtful process to more deeply evaluate. Another area of research, as I mentioned, is to look out into the Milky Way galaxy, our galaxy close by. So in the grand scheme of the universe, our galaxy is very close to us. And when we look out into certain parts of it, we can discover quite a few things, in much more detail and much more richness than we can for things that are outside of our galaxy. For example, in the next galaxy, which is called Andromeda. So here we are in the Milky Way, and looking out at it, and we used one of the most profound observational instruments for this area of research was a space telescope called Kepler, which was active for many years and only recently went out of use. And it was pointed into an area of the sky near the star Vega, near what's called the Summer Triangle, which is rising up in the east this evening. And that area of the sky, we discovered, was very rich with a lot of interesting stars and exoplanets. So here's a little summary. It spent 10 years in space. I love the fact that it took 3 gallons of fuel to run it, which is great. It observed 530,000 stars during that almost 10-year period, and in doing so, confirmed 2,662 exoplanets. Isn't that great? It's an amazing collection of discoveries that was made by one space telescope. Now, many of those planets that were discovered are what are called the big, hot Jupiters. They're very big planets, And of course, they're easier to discover because they're larger, and when they pass by in front of their parent star, for example, and they block out that star for a few minutes or hours, it's an easier thing to detect. But there were also many planets that were confirmed that are much more Earth-like in size, and therefore have become some of the candidates to more deeply evaluate and study in the future. So once again, here was a fantastic mission that up until a few years ago was active, and it's given us the foundation for where to look next. Another area is looking out into the entire universe, not just the Milky Way galaxy, but far, far beyond, and just listening. And that work is predominantly being carried out by an organization called the SETI Institute. And SETI is an acronym for Search for Extraterrestrial Intelligence, the SETI Institute. And it's been active in this research for in about 50 years, of which about 30 of it have been very much a disciplined series of studies. And you can see on the screen right now, what is SETI? The core of it are those antennae that are pointing out into space. That's the core SETI research for listening and trying to find intelligence. But the SETI Institute also is studying exoplanets and astrobiology and regular old astronomy and astrophysics and things like climate science and climate change and biogeoscience, because by better understanding our Earth and all of the elements in it that have made life happen, we can begin to better understand our neighbors in the universe. I'm a huge fan of the SETI Institute. By the way, after this talk tonight, if you get interested in this, you can find so many videos on YouTube from the SETI Institute, so many really extraordinary pieces of research. They are a real treasure trove of the deep thinking that goes behind the search for extraterrestrial life and extraterrestrial intelligence. So I am a massive fan of what they do. And one of their early visionaries and voices was a very well-known scientist in the United States who is also an author named Carl Sagan, who wrote a book series called Cosmos. He also wrote another book called Contact, which was turned into a movie. I've got a picture here of Jodie Foster as the scientist. And if you want to get a really great science fiction movie that plays out the scenario of making contact with an intelligent life outside of our own Earth, this is the movie to watch. I really recommend it because it explores it thoughtfully, and it takes you through all of the steps of what it could be like if we were to establish contact with extraterrestrials. And I find it to be responsible and scientifically accurate, and also, of course, delving into science fiction, but in a way that is grounded in the science behind it. So if you ever want to watch that, I'd highly recommend that movie. And the fourth thing is what's called sometimes not SETI, but METI, the messaging to extraterrestrial intelligence, right? Us sending out signals to make ourselves visible and understood. So once again, think about it. We as Earth, interestingly, for almost 100 years now, have been in the business of transmitting. Actually, more than 100 years, we've been using radio frequencies to transmit signals from place to place. And then our technology got better with satellite communications, and we have become a very noisy planet. And we're sending out in all different parts of the spectrum very interesting intelligence. So we have already, whether we realized it or not, been communicating to the rest of the universe, hey, we're here, in the form of a lot of television programs and God knows what, right? All kinds of interesting things that we're streaming out into space 24/7. And what that means is if you're in a circle of the nearby Milky Way galaxy on one of those stars and an exoplanet around one of those stars, within 100 light years of our solar system, you could be listening in right now to old reruns of a TV program. Who knows? So that's possible out there because we're transmitting. But in 1974, scientists went to this antenna, it's called the Arecibo radio antenna. It's in Puerto Rico. And they created a 3-minute message. And the picture you see here, this middle picture, is the digital encoding of some basics, like how to count to 10 in binary, and some numbers from our atomic table. And as you can see, pictures of Earth and the antenna that transmitted this signal. And they pointed it in the direction of the globular cluster, the M13, which is the Great Globular Cluster that you see on the right, which is 25,000 light years away. So what does that mean? For 3 minutes, we transmitted 1 megawatt of power directly, very narrowly focused in the direction of that star cluster. And we sent this very unique encoded signal. And now it's racing there, right? So from 74, what is it, 84, 94 or so, 46 years later, that signal has traveled 46 light years. It's got 25,000 light years to go before it gets there. But by the time it gets there, there might be some ears and eyes that are looking out for those signals and listening for them, that they'll pick it up from us. Sadly, it'll take us 25,000 years to get there. That's a very long time, obviously. And if you send it in the direction of a cluster of stars, your hope is maybe there's a lot of exoplanets around those stars, and there's a higher likelihood someone might be listening and hear that and do something with it. But it does beg the question, do we want to be doing this? That's a question we'll come back to. But this picture right here is actually a very real image of, not a very real image, it's a very real scientifically fabricated visual in 3D of what are the stars, both the small red dwarf stars as well as the bigger stars that we come to know, that are within 100 light years of where we are on Earth. And everything in that sphere, if they point their telescopes, their radio telescopes at Earth, they're going to pick up on all of these signals that we've been putting out there. They'll know there's some intelligence in that direction, within 100 light years of where we are right now. We also have sent out some space probes that very intentionally have been pushed out of the solar system and are on their way now in what's called intergalactic space. They're no longer in the realm of our solar system. The Pioneer space probes and the Voyager space probes, there's 4 of them now traveling out of the solar system. The 2 Voyager probes we're still in contact with. It's incredible. There's something like 25 billion kilometers away from Earth, and yet we're still able to communicate with those little tiny transmitters that were launched in the 70s. But on each of those Pioneer and Voyager satellites or research probes, we put imagery, as you can see on the left, or on the right we have the famous golden record, which has what's called the sounds of Earth. People speaking different language, people expressing emotion and singing, and coming from all parts of life and all walks of life from Earth. And a lot of other encoded data that's helping someone who someday in the future may stumble across one of these probes and wonder where it came from. So should we be sending a map of where we are out to some aliens out there that might pick it up in 10 or 20 or 50,000 years? Interesting question. So let's talk about the next generation of research for extraterrestrial life. And that would be the same areas we just covered, but in a more modern way. We've begun visiting solar system objects. We already have a survey of what's out there. And now we're going back to the most interesting ones. We're peering deeper and deeper with better and better telescopes into those exosolar systems and exoplanets. And we're continuing to improve our SETI capabilities so that we can more carefully analyze the signals we're receiving from space to see if we can decipher intelligence in any of those signals. It's unlikely we're going to do any more of these special communications. So for what it's worth, that's such a controversial thing. There's no one out right now planning to rebroadcast and further transmit very unique and very high-powered signals into space. But as I mentioned before, every single day of the week we're transmitting noise into space anyhow. So we're making ourselves quite visible, and we're kind of a glowing orb in the solar system and in the Milky Way galaxy if anyone has the interest to look toward us within 100 light years. So let's look at future area of research number 1. Going back to the places we deem most interesting: Mars, Enceladus, Titan, Europa. So the Europa Clipper is supposed to go live in a couple of years, and it's going to be going back to Europa, but very carefully focused on looking for those signatures of life, on analyzing and trying to understand as it flies around the planet and as it drops a lander, onto the moon. These are moons. What could be there? And are there any possibilities inside of our own solar system to discover perhaps these microorganisms? Or if not the microorganisms, like when we go to Mars, we haven't found any living objects on Mars yet. But the big question that we're still asking ourselves, and we have rovers up there to look for this, is there potentially the signs of past life, which would already be interesting enough. Even if it's not living anymore because the conditions on Mars are too cold, might we find little exoskeletons of microbes or small animals that once did live in the sands and the soils of Mars? Hence, we have probes roving around right now, and we're building up yet better and better probes. And every generation that goes up in the sky now is very well designed and focused on looking for any of those clues, any of those characteristics of what life would exhibit. We're also looking deeper at those exoplanets, so that the Kepler Space Telescope identified hundreds and even thousands of exoplanets. And now the task is to subset those and find the ones that are the most Earth-like from our point of view, and then peer deeper at those with the next generation of tech. So for example, there's something called the James Webb Space Telescope that, if all goes well, might finally go up into space in a couple of years. And it is enormous. And if it's up in the sky, one of the most important tasks it's going to be doing is looking at those same exoplanets, but looking at them a lot more closely, with a lot more magnification, and giving us much better resolution, and the ability then to look for those biogenics and the side effects, the gases that they give out. A third area is, of course, SETI. Right now, the SETI Institute, which is based in the Silicon Valley area of California, has 42 telescopes. It's called the Allen Array, and it's based in Northeast California. And those 42 telescopes at all times are peering into the sky, and they use different types of amplifiers and different kinds of filtering systems and different kinds of technology inside those little receptors to continually improve and enhance the quality of their research as they analyze the sky and try to sift something out of the noise. The gentleman, Seth Shostak, who's one of the main spokespersons at SETI, often compares it to when you would be driving in a car and you have an old AM radio and you're tuning the dial and you just hear noise. And as you tune, suddenly you get a little voice. You hear something more clearly. And that's what they're trying to do at SETI. They're trying to scan all those frequencies and be listening and very carefully trying to filter out, is there something we're getting in that is an intelligent signal? But SETI originally was designed to be 300 telescopes. That's their goal. And if they could ever get that, well, then they're going to have 8 times the magnification, if you will, 8 times the capability of detecting even more sensitive signals. It's a question of money. In many of these scenarios, it's a question of budget and commitment from governments, whether it's in the United States or in Europe or in Asia, that helps to support these projects and make them happen. So there's a quick look at some foundation ideas and some of the areas of research that are going on right now. And now I have for everyone some challenges and some questions I want to ask. So, first question, which is the core question of anyone who thinks about extraterrestrial life and extraterrestrial intelligence, is, are we alone in the universe? And one of the more interesting hypotheses, the so-called rare earth hypothesis, it's quite a vast field of study, is basically in short says, to get what we have on Earth required an improbable combination of astrophysical and geological events and circumstances over a 4 billion year period of time that led us to where we are now. And the odds of that happening anywhere else in our entire universe are incredibly improbable, and we're probably it. What do you think? It's kind of sad. That's the way it is. That's one hypothesis. It's one way to think about this. We can search and search and search, but the fact that we found nothing is a little bit of a warning sign that there probably isn't anything out there. So that's one interesting angle. Another angle is that civilizations, let's call them intelligent civilizations as we defined it earlier, just don't last long enough to have two-way communication. If you think about Earth and human beings, we've been civilized, so to speak, for about 10,000 years. And we've been very modern with our technology for only a couple of hundred years. And already in our run-up, as you know, what defines intelligence? Our ability to adapt and manage our environment, and our ability to build and enhance technology within society. And have we done so in a way that's already put us on a collision course for extinction because we started warming our planet? And that may be just illustrative that when you have a very advanced and technologically sophisticated society, that it can lead to some very real problems that can cause them to extinguish themselves. And if so, how many civilizations have there been in the history of our universe that have come and then gone, and there's no trace of them left, and they were gone 100,000 years ago, or 1,000,000 years ago, or 1,000,000,000 years ago, and we have no chance of ever even knowing they existed? Or conversely, will anyone ever know that we existed? Another challenging thing to think about is the fact that right now, as we're standing here, as I'm standing here talking with you through the internet, there are signals coming in from space, and the SETI Institute is listening to those. What if there's already messages encoded in those signals, but we're just not advanced enough yet to actually filter them out and understand them? And the extraterrestrials have been communicating with us since the beginning of time, but we just don't have well enough trained ears, so to speak, to hear the words they are saying. It's a possibility. Another interesting one is the fundamental question that if we get a contact someday, who speaks for Earth? Who's in charge? Who's going to give out an answer? Or are we going to give out an answer? Do we even want to tell the guys, hey, we heard you, we'd like to communicate back? It's an excellent question. And therefore, the question of should we radiate at all? And we're giving away our position all the time. Should we mitigate all those signals we're pushing out into space and never try to transmit very much at all, or never intentionally transmit to try to reach other alien life? And what if those aliens have bad intentions? How are we going to know? What can we do to stop that? We haven't had a direct experience enough to know that, but it's a great question to be pondering. And what about even here in the solar system, when we're sending out probes to go to Europa and Ganymede and Titan and Mars? What if we bring germs and microbes from Earth? Are we going to despoil and pollute potentially other pristine virgin worlds that have never been exposed to anything? And maybe there's microbes there, and we're going to show up and we're going to kill them off. Kind of like, when the Spanish conquered the people in Central America 500 years ago. So really interesting, challenging questions. And believe me, the folks at the SETI Institute, I've come to know some of them personally, they grapple with these issues and really think about that and worry about that and turn it into actual papers and into real science. So we didn't have the answer tonight for little green men, and we don't have an answer except maybe to help you to ask more questions and to ponder and to think. So let me stop right now and go back to Benjamin, and maybe there's a few questions that have been put into chat, and we can spend a few minutes talking about those. Benjamin?
Yeah, thanks, Paul. Very much thanks for that interesting talk. And I always waited for questions in our live chat. Maybe people are typing right now, and maybe the questions will pop up in a minute. But at the moment, we don't have any questions here, which I really don't understand. So I'll start with a question of my own, if I may.
Great.
Okay, so regarding that rare Earth hypothesis you talked about.
Yes.
I just read in scientific news a few days ago that it could be possible that the solar system is just in a very unfavorable position for visits or for contact by aliens. So they compared it to a small habitable island in a vast ocean. So what do you think about that theory that would explain why humankind doesn't see any traces of extraterrestrial intelligence?
Yeah, that's a great way to think about it, using the metaphor of an ocean and a tiny island in the middle of an ocean. Our Milky Way galaxy is, our solar system is part of a galaxy. And we're not at the center of the galaxy, we're a little bit out on the fringe, on the edge of the galaxy. Not on the edge, but we're on a spiral arm. And our neighbors within 100 light years, there are dozens of stars, if not hundreds of stars, that even in this local area where we are around us. And then you have our galaxy, and then we have the Andromeda galaxy 2 million light years away. And we have our entire local group. And in general, we're not particularly in a very sparse area. So to be honest, we are just as good or equally interesting as anyone would be looking at the Andromeda galaxy or the Triangulum galaxy or other galaxies in this area. So we certainly have the potential to be very discoverable. One of the hardest questions about us being found by others and others coming to see us is just a simple question of speed of light, and the fact that even the nearest stars, which are 4 and 8 light years away, you'd have to be going at the speed of light. And we as human beings don't even know how we could ever get anything going near to that speed. So the idea of moving across our galaxy to the next stars is already an unimaginably complex thing for us. Trying to envision that aliens or extraterrestrials can come and find us, they would have a similar problem. They've got to move across these vast distances to find us. But if you're within 100 light years, you can certainly hear us. So at least without having to even put a spaceship into flight, if they're just listening carefully within 100 light years, we're detectable. We would be, and in fact, for several billion years, we've been detectable if someone was to measure our atmosphere as it's evolved over the last several billion years, because it would have already been showing those symbols, those components that in the atmosphere that would tell you that there's life happening down on the planetary surface. So I don't know. I'm not sure that we're just hard to find, Benjamin.
Mm-hmm.
Good question.
Yeah, I think so too. So if you assume that there is extraterrestrial life, intelligent life maybe, then the only reasonable explanation would be that maybe other intelligences may not want to get into contact, and there may be even good reasons for that. But so which leads me to my next question. I really don't understand so well why so many people are interested in the question so deeply. So it's always one of the first questions we get in the observatory if people visit us. Is there extraterrestrial life? Do you think there is life in the Milky Way or in the near surroundings of the solar system? So what do you think? Why do you think the question is so interesting, it's so important?
It harkens back, I think, to humankind. If you look at humankind over millennia, and you look at the evolution of different types of world religions, and of different kinds of philosophical trains of thought, almost all of them come back to a set of very fundamental questions. Why are we here? How did we get here? What's going to happen when we die? What's going to be the fate of our Milky Way galaxy and our Earth? And finally, are we alone in the universe? And these questions come up again and again and again, whether it's in the present era or, for that matter, 2,000 years ago in the early civilizations of that time, the Romans and the Greeks. There were, and before that still, there were always the deep thinkers that would come back time and time again to these fundamental questions. So I would say it's a fundamental question, but because we work with people who are interested in astronomy, they're naturally drawn to the question when they look up at the sky at night to ask themselves, is anything out there? So I think it's just in human nature that we as a species are very curious about that, because it runs through the fabric of our consciousness.
Yeah, I think you talked about that question a bit more deeply in your talk last year at the TEDx at the Technical University.
Correct, at the TEDx talk. Yes.
Yeah. So for all of the people who switched on the live stream afterwards, I gave the introduction. You have it in the video description. So this talk is also watchable on YouTube. There I see there pops up another question in the live chat. Okay, that's a nice question. So regarding your plans for going out into space, Paul, which planet or moon would we be most likely to colonize in the future? What do you think?
To colonize. Okay, that's a different question. So one of the things I talked about earlier was just exploring and looking for life. But colonize is Mars, hands down. Well, the moon, of course. We've been there. We've successfully landed there, and we've proven we can exist, if nothing else, for a day or two or three, and then leave. And certainly in the current trajectory with NASA, with ESA, and with the support of commercial institutions like SpaceX, there's very realistic and very solid plans, first to go back and colonize the moon, and to build an orbiting space station, kind of like we have the International Space Station around Earth, to put another one around the moon. And then using that as a base and as a place to experiment with living in another world, then jettison out to Mars and start to colonize Mars. So I would say of all of the major space institutions around the world, from China, from Russia, from Europe, from the United States and Canada, the first focus is the moon and then onto Mars. Those are, from colonization point of view, hands down, that's what's planned. And the challenge is this: we don't have many other options. Venus is inhospitable. We couldn't live there. Mercury has a lot of difficulties because it's even much more closer to the sun. And the outer planets, Jupiter and Saturn and Uranus and Neptune, are gas giants. You can't land on the surface. There is no solid surface. So for colonization, it's the moon and it's Mars. Maybe an asteroid someday, perhaps, but that's not something that I've heard of yet.
But I think that may be sufficient for the first steps. And on the other hand, it will be kind of a contradiction to what you said before about being careful where humankind would send their space probes, because maybe you could destroy the traces of life which have emerged there before or something.
Correct. No, that's a very big. There's a particular individual at the SETI Institute who's quite well known, and I guess can't think of her name, but is the leading sort of thought leader in that subject of how, if we're going to send a probe to, let's pick a different thing like Enceladus, the moon around Saturn, or Europa, the moon around Jupiter, and we're not going to send people there, but we are going to send robotic probes that are going to go and evaluate and understand and try to land even. And there you have a very real possibility of contamination. And we think about that. I mean, it is a very deep topic for those that are in the solar system exploration business.
Contamination may be a good word, leading to another question from our live chat. So there's someone who is guessing that maybe the aliens know more about us than we would guess, because he's asking what Oumuamua was, what kind of object, and poses the question, who would contact an armed civilization like us?
Yes, exactly. I mean, at least let's frame it in a couple different ways. If the other aliens that are coming to get to know us are similar in terms of their technological advancement, then they might find us a bit frightening. But that's a big what if. Yeah, you have to really assume that their technology advanced just as ours did, and there's no reason why in 5,000 years or 10,000 years we might have much more advanced technology and artificial intelligence and robotics. Who knows? So it's a tricky thing to ever assume that these aliens are going to think and behave and even have emotional reactions like fear in the same way that we do. We don't know. It's a very, very difficult thing to try to guess. This particular object that flew by, the unique thing about that object was that it was most of the objects that fly by close to Earth and are interesting to look at, asteroids primarily, and comets from time to time, come from within our own solar system. So these are asteroids that are already in orbit around the asteroid belt, and they get knocked out of whack and they come close to Earth and they fly by, or they have an orbit that's closer to the sun and we have to deal with them. Or they're comets that come from the Oort cloud or the Kuiper belt and fly in from very far away, but still within the solar system. But this particular object, and to be honest, without reading the word, I can't even say the name, Benjamin. I always forget it. How do you say it?
It's called Oumuamua.
Oumuamua, thank you. Hawaiian name, if I'm not mistaken. Probably because it was discovered in Hawaii, I would guess. But it came apparently from outside of our entire solar system. So it was a true interloper from interstellar space that came very close by and then right out again. So I believe, if I remember what I read about it, it's a one-shot wonder. It came through, it did its flyby, and we're never going to see it again. But it was truly not from our own solar system, which had made it more interesting. But by no means do we have any evidence that therefore contained extraterrestrial intelligence on board or anything else except a happenstance rock from space that flew nearby, as best I understand it. Unless you've heard something different, Benjamin.
No, that's right. So there was a lot of guessing about that object, but as far as I know, this has been the conclusions have been drawn, and then all the parameters of the orbit of that object could be explained by natural phenomena.
There we go.
So, yeah, maybe that already leads, to the next question, because this object was from interstellar space, and if you imagine, intelligent life, going through space, they would of course need spaceships. And wouldn't it be possible to detect traces or to see such spaceships or find some of their remnants or detect the energy output of that spaceships as well?
Well, for sure. Yeah, I mean, we certainly have the technology to do that, right? So if there was a spaceship being launched off the moon right now, I think we would have the capacity with telescopes and with radio telescopes to detect that with infrared as well. It's an interesting, let me flip to a different angle on this, Benjamin. Another angle is that you would have this object flying in from outside of our solar system. If you're going to fly for that long to come to another solar system, for example, if we wanted to go to Alpha Centauri, which is 4 1/3 light years away, at the speed of light, it would take us 4 years. Not at the speed of light, it might take us 4,000 years to get there, right? So what if we were to get an asteroid where we could set up a colony and live there because we have resources, we have water and carbon and the elements of life, and we can plant ourselves on there and then accelerate ourselves in the direction of Alpha Centauri. Now that would be an interesting thing. Rather than sending a spaceship, we actually take a whole asteroid with us because it's also going to have all the raw materials we need to sustain life for thousands upon thousands of years of time that it's going to take to get to that next star. So that would be a reason for flipping it around the other way for maybe another civilization to build a little outpost civilization on a rock, call it a rock, a big rock, an asteroid, and then catapult that across space and hope that they're going to fly through another solar system and maybe make some contact. That's a fun hypothesis to work with. It's a clever idea and one that we could tinker with a bit.
Yeah, I think this was thought about a long time ago, and there were a lot of science fiction books and movies with a scenario you described, and that was one of the reasons why Oumuamua was seen as kind of like an interstellar spaceship or like an asteroid, with intelligent life on it. But yeah, as said before, it turned out that you could explain everything by natural phenomena as well.
Yeah.
So I don't have any more questions in the live chat on my list. So may I pose a final question for you, which always is posed in our observatory to me as well, which is, do you personally think that humankind will find proof of extraterrestrial life, not intelligence, only life, in near future, or maybe already in our lifetime?
I do think that's very realistic. I think that the kind of space probes that we're developing now do have the potential to go to Enceladus, to Titan, to Europa, and find it. And if we get human beings on Mars and we begin to do even deeper analysis of the soil, that we could find remnants of life, perhaps. Maybe not existing life, but past life that left behind its bones, so to speak. Yeah, and as well, with the James Webb looking at exoplanets, with increased and improving technologies from other extremely large telescopes that are being planned right now, it seems completely rational to say that in the next, let's call it the next generation of space technology, right? The next generation of robots traveling out to moons and planets, the next generation of telescopes being launched into space or built on Earth to look at the sky, that we're going to get a close enough look at these exoplanets that we'll be able to more accurately and potentially correctly pinpoint some of them that harbor all of the characteristics of life. So I think that we are in the generation right now where over the next 10, 20, 30, 40 years, the caliber of the instruments we have will allow us to peer out even more deeply. And we're doing it in a very focused way. We're doing it in a very narrowly defined way. We're not just randomly looking everywhere. We're narrowly looking at the places that have the highest likelihood. So for that reason, I think it's a very probable outcome. I think it's an exciting time to be in this subject and in this field. And I'm just thrilled to death every time I think about how great it is that we have governmental institutions around the world, and we have scientists that dedicate and commit themselves to this type of research and spend the money on it. I think it's money well spent and money well invested in understanding ourselves and our place in the universe. Okay,
I cannot add anything to that remarks, so I will just have some kind of remarks regarding our next plans for online presentations. So, Paul, you talked a lot about exoplanets, of course, because they could harbor maybe life in any form. And there is one recorded talk we will upload to YouTube in a few days or weeks, where one of our club members is talking about detection of exoplanets. So not only the Kepler Space Telescope can detect exoplanets, it can also be done by amateur astronomers, of course, with a lot of preparation and yeah, it's no easy task, but it can be done also by amateurs, and we'll have a talk about that topic on YouTube, not as live stream. It will just be a recording, so stay tuned. Drop in from time to time, or what you also can do, you can register for our newsletter. You just have to go to the website of the Volkssternwarte and navigate to the contact site, and then you can sign in for our newsletter. So we would be very happy if you tune in for our future offerings here, and we would be even more pleased if you can visit us in our observatory. Maybe we can reopen in the next weeks or months, but there is no really final plan for that at the moment. So I cannot promise anything, I'm afraid. One thing which already also is dependent a bit from Paul is when we will be able to offer that lecture in German as well. So in our lecture program, it was planned in 3 weeks, I think. Paul, do you have any plans already for this talk in German?
I'll be happy to do it again. Yes, it'd be a lot of fun to do this all over again and make it accessible for our German-speaking audience, of course. So I'm planning on that myself. I've got it on my calendar, and I'm happy to do that.
Okay, so maybe we can fix the date, and then, of course, we will announce it here and on our website. Again, thanks very much, Paul. Do you have any final remarks for the audience?
No, just want to say thank you, everyone, for taking part, and I hope that you were able to get some new ideas that are fun and interesting and challenging to think about. So enjoy that, and have a good evening, and hopefully we have some clear skies in Munich soon, and we can get out under the night sky and enjoy that too.
Okay, have a good night, and see you soon.
Thanks, Benjamin.